This video is about the reaction quotient, which is abbreviated capital Q. This is related to the chemical equilibrium constant, which is capital K. So this is the kind of problem where reaction quotient is relevant. Consider the following equilibrium reaction. You're given the equilibrium constant Kc is 9.60. If you mix 2.5 moles of H2 with 1 mole of N2 and 2.5 moles of NH3 in a 1 liter container, is the reaction mixture already at equilibrium? If not, will it proceed to the right or to the left to achieve equilibrium? So here you're going to calculate the reaction quotient, which is basically where the system is. Is it near equilibrium or not? So for our general reaction, AA plus BB goes to CC plus DD, our equation for the reaction quotient Q is given here, where the brackets mean molarity, and then each of these concentrations is raised to the power that matches the stoichiometric coefficient. So it looks a lot like K, except the difference is that in this case, these concentrations are at any point. They're not necessarily at equilibrium like they are for the equilibrium constant. So you can plug them in at any point in the reaction, the initial concentrations, whatever, and then you compare Q to K. If Q equals K, then you're at equilibrium. But if it's not equal to K, then the reaction will move in one direction or the other to achieve equilibrium. So that's what this image is showing you from the book. The middle image is when Q equals K, and that means that you're at equilibrium because you've plugged them into the equilibrium constant expression or the reaction quotient expression. And when they are equal, that means that you're at equilibrium. If Q is less than K, then if you remember, these are both sort of the products in the numerator divided by the reactants in the denominator. And so if Q is really low and is not nearly the same as K, is much smaller than K, that means that the products, there aren't enough products. Your numerator is too small, your denominator is too large. Therefore, Q is going to, the reaction is going to move to the right to form more products, fewer reactants, and that's going to cause Q to rise until it gets to be equal to K. If, however, Q is larger than K, that means that your numerator is too large, which means you have too many products, which means the reaction will proceed to the left, as you see here, until, again, Q equals K. So in this case, the reaction proceeds to the left, the numerator gets smaller, the denominator gets bigger, Q goes down until it equals K. So in the middle, Q equals K. That's at equilibrium. On the right, Q is greater than K, so the reaction proceeds to the left. Q is too big. You have too many products, right? Too many. So we have too many products. It's going to move to the left to form more reactants. That should say too many products over here. Q is less than K. That means Q is too small. This one is correct. You have too many reactants in the denominator, and that means it's going to proceed to the right. So in this calculation, you just plug in the values that you're given to the Q expression. You should always start by writing the Q expression, otherwise you're going to forget to square it or to cube it. So we plug those numbers in. Remember, the brackets are molarity. So if this were not 1 liter, you would have to divide by the volume, right? We're dividing by 1 liter here. Q equals 0.4. We compare that to K, which is 9.60. Q is less than K. So Q is too small. So if you again look at the Q expression, in this particular case, in all cases, the products are in the numerator, the reactants are in the denominator. So when Q is too small, it means you don't have enough product. Your numerator is too small. That means it needs to move to the right to increase the numerator, decrease the denominator to make Q a larger number until it equals K. In this particular case, it means you don't have enough ammonia. You have too much H2 and N2. So the reaction is going to proceed to the right to make more NH3 until Q equals K. So we have to actually answer the question. The reaction moves to the right.